So this lesson is on vector equations, and we'll also use vectors in coordinate geometry in a minute too. Vector equations are quite straightforward and simple to solve because they follow the same rules as any real number, so normal equations, algebraic ones that you've come across. The only thing is we tend to never write the vector as a numerator or denominator of a fraction, because the vector, for example, a over 2 has no meaning in vector algebra. It does not have a meaning. In my head, I think of it as if I were to divide a vector by 2, I would not only be dividing its length by 2, but also its angle or direction, which doesn't make sense. You can't divide a direction by 2. So we write it as a half of a instead of a on 2. So to solve 2x equals a for x, we just divide both sides by 2 and we get this. So like any other algebraic equation. Some other useful and simple rules: x plus a equals b. If I just want x, I'd take a from both sides. Kx equals a, then x is 1 on k times a, where k is a scalar, so k is not a vector in this one. Scalar, if you have forgotten, is just any number, any real number. In these examples, I'll quickly go through them. If I just wanted to make x the subject, I'd move r over, so it'll be s plus r and then divide by 3. So it'll be a third times s plus r, or you can write it as a third s plus a third r, the expanded version of it. And it's a similar case for part B. In your GDC, your graphic display calculator, you can actually process vectors using the matrices. So you'll find the the bracket there with 2 boxes for you to enter a value, and if you put in the vector, it'll actually process them for you. So -2, 4 plus 6, 8 is 4, 12. The other good thing about it is you actually should use the storage of a variable in your GDC, because it saves you having to type out 4, 1 every single time you want to use P, and 2, -3 every single time you want to use Q. So if you've stored the variable P, then you can just type a half P minus 3Q, and it will process it with the value that you've stored P and Q as in your calculator. However, you need to make sure you actually clear your memory of the the whole alphabet that you might have assigned in previous years. So in year 10, you might have assigned P equals 6 and Q equals 10 and have forgotten that you'd done that. And your calculator would still remember, though, that you'd enter those values. So before you store any variables, you need to actually clear your memory. Go to Menu, Actions, Clear A to Z. Okay? If you wanted to find the length of a vector, you can just choose Menu, 7, and 7 for norms. And norms is the calculator's way of saying find the length or the modulus of the vector. I know I keep saying modulus. It's because that's actually the technical name that we use for the length of a vector. When we say, we don't really use length of vector, or some of you have said the little absolute value sign. That's not really correct. We say modulus. Now, vectors in coordinate geometry. This is the part where it gets interesting, because it actually lets us solve problems and apply vectors to situations where you probably didn't even know that you could have used vectors in. So the first example is if I labeled this point A1, A2 instead of x1, y1, x2, y2, we're using A because that's going to let us refer to point A. So linking those points to A. And for B, you guessed it, B1, B2. So these coordinates, though, they're from the reference point of the origin. So if I said that was 3, 4, that's saying it's 3 across from 0 and 4 up from 0, right? We'll come back to that because that's important. So if I wanted to find vector OA, then that would be A1 minus, well, it would be A1, A2. And OB would be B1, B2. And those are the points relative from 0. If I wanted to get AB though, that would actually be, if I draw in this line here for you, to get head to tail, I'll need to flip OA, right? So it would be OB minus OA. That would give B1 minus A1 over B2 minus A2. So in short, it's essentially the second letter minus the first letter, B minus A, B minus A, okay? As a short example here, if I wanted OA, A is second, so it'll be XA minus 0, which is XA, YA minus 0, which is YA, okay? I'll do example B for you here because A and C are similar and straightforward. If I wanted the position vector of B from A, that's asking for vector AB. B from A is saying A comes first. That means it's going to be 3 minus negative 1 and 4 minus 2, which is 4, 2. Now, it's tempting though, because you're so used to finding like the gradient and distance and all that. For gradient, you'd put the y first, but no, in vectors, you keep it in the horizontals on top and the verticals on the bottom. So you still group them together. You do the x's first because that's on top. You can do the y's first, but you have to fill in the bottom first then. In example 2, this is an interesting one because you never would have thought that you could apply vectors to finding the coordinates in this. We've got AB is the diameter, C is the center. B has coordinates 3, 1. Find BC and the coordinates of A. So for BC, that would be C negative 1 minus 3 and 2 minus 1, which is negative 4 and 1. Now for the coordinates of A, I'm going to put in a dummy first. So I'm going to let A be A1, A2. So I've used the congruent sign because that's how you assign, that's how you say you don't use the equal sign for coordinates. That's A1, A2. Then BC is this vector. That means that CA should be the same vector because they're both radii and they both construct the diameter, and the diameter is double the radii. So using that knowledge, we can say that CA is equal to BC. In vector form, we're saying CA, so A1 minus negative 1, A plus 1, A2 minus 2 is equal to BC, which we've already found as 4, 1. In order for this to be equal, we would need A1 to be negative 5 and A2 to be 3. So A has coordinates negative 5, 3. Right? Now for distance, as I said, we denote it using the absolute value sign, and we call that actually the modulus. Okay, so if you hear me say modulus, you could think distance or length, either one, they're like synonyms. We also, for this example, I'll quickly go through that as well. For vector PQ, 3 minus negative 1, 4, 1, negative 1. Right, so the length of it would be root 4 squared plus negative 1 all squared, which is root 17, which we've previously done. So that is like us using the distance formula. Okay, For vector equality, we can say two vectors are equal. Two vectors are equal if and only if, so IFF means if and only if in maths, P equals R and S equals Q. So only if these two are equal and these two are equal, that they must then be two equal vectors. For this example, the saying find the coordinates of C and D, given that these are all equidistant. So I'm going to put in this vector then, and if that is the same length as this one and they're all along a straight line, then AB must be equal to BC, which must be equal to CD. So first, if I have AB, that would be -1 plus 2, -2 plus 5, 1, 3, right? And I want to also find BC. So let's just say C has coordinates C1, C2, D is D1, D2. Then that would give C1 plus 1, C2 plus 2. That's equal to 0, 1. That means that in order for this to equal to the same vector here, C1 must be 0 and C2 must be 1. 1 plus 2 is equal to 3. That means that, let me write that again. That should equal to 1, 3. Therefore, C1 equals 0 and C2 equals 1, i.e. C has coordinates 0, 1. And you can do a similar thing for CD. That would be D1 minus 0, D2 minus 1, because we've got those coordinates there. That should equal to 1, 3. Therefore, D has coordinates 1, 4. Right? For the next part, I'm quite confident you'll be able to do these questions, but for example 3, I'll quickly go through this one. My document's just gone a bit funny. So they're asking us to find the remaining vertex of A, B, C, D. So I've assigned vertex D as X, Y. You could do D1, D2. I thought I'd change it up. We know that vector, because it's a parallelogram, because opposite sides are parallel, then vector AB should equal to vector DC. So vector AB would be 2 minus -1, 2 plus 1, 4 minus 3, and -2 minus X, -1 minus Y. Now you've got 3 and positive 1 equals -2 minus X, -1 minus Y. So hence, -2 minus X equals 3. So X equals -5, and 1 equals -1 minus Y. So we're just equating the vertical and horizontal components to give D equal to -5 minus 2. You can use that, use that knowledge, and you can go on to example 2 and finish them off.